let's have a quick whip through all integration. On the principle, it's been a bit light in paper 1 and paper 2. So get a checklist in your head. It could be on the formula book, but if it is, it won't be simple. For example, these two questions. First one is easy. If a fraction is top heavy like this, you can just break it up, and that's an easy integration. Just tidy the powers up there. Easy. Whereas this one's a hard one. It's got a lovely trick. And that is I add 1 and subtract 1 from the top, obviously not changing the integral. And now I can break it up into x plus 1 over x plus 1. That is 1 minus 1 over x plus 1, which is easily done. The next, it's just really good if you can do these without any working. And these are ones that are nearly the formula book. A linear transformation of the formula book, you just write it down. 2x plus 3 to the n. Well, that's just 2x plus 3 to the n plus 1 over n plus 1. Then all you have to do is remember to divide by the 2. This is like the reverse of the chain rule, but it only works for linear functions. So this one here is just like 1 over x. So you just say, well, it's obviously log of 2x plus 3. As long as you remember to divide by the 2, and this one comes up all the time, the integral of e to the 4x, well, that's the same as the integral of e to the x, but I've got to divide by 4. Always on the lookout for f dashed over f, but it doesn't have to be exact. So this one here, well, sorry, if it is f dashed over x, we can just write down that as log of f of x. That should have absolute value inside the logarithm there. So if it is f dashed over f, it's log of the bottom. Now this one here, obviously when you differentiate the bottom, you get minus 8x, and I don't have that. So I make an adjustment. I take the 3 out of the integral. I put a minus 8 in, which means I have to divide by minus 8. And so I get the nice answer of minus 3/8 of log of the bottom. That should be a 4. What have I done here? Fine. And so the integral of tan x is probably the most famous one. When you differentiate cos, you get negative sign. So I put a minus sign in and take 1 out, and now I can write the answer down. And I could put that negative into the logarithm as a power. So the famous answer is log of sec x. Maybe the question is the integral of 7 cos squared x. First thing I do is take the 7 out. And this is just one you've got to learn. When you see cos squared or sine squared, then we're going to use a bit of trig magic where we take the standard formula for cos 2x and rearrange it so it looks like that, plug it in. I took that awkward half out of the integral. Really like to take these multiplying constants out so they don't distract me. Now I just have to integrate that. That is a linear substitute of the formula book, dead easy. Partial fractions, it's only the easiest partial fractions case. This is the only case there is really. X squared minus 4. And so we split it into its 2 fractions. You should know the method for doing this. And now the way I do these is that they are f dashed over f, nearly. That one is exactly f dashed over f. For this one to be f dashed over f, I would take the 3 out. So it's 3 log x plus 2. Nice. If the substitute is obvious, then it's up to you to find it. So in this top one here, clearly the substitute is u equals 4x cubed minus 5. And I won't tell you how to do integration and substitution in this video, but when you differentiate the substitute, which you can do in your head, you say to yourself, is it likely that I'll be able to cancel that out? And that's an indicator you've chosen the right substitute, which clearly we have in this case. This one here, where it's not at all obvious what the correct substitute is, then they can be quite hard questions. And you just got to follow the procedure. In this case, t equals tan x is very difficult, and I think they would guide you through this. But the fundamental rule is you differentiate it, and you find out what dx is, and substitute that at the same time you substitute other things. It's just that this question is extremely hard. And lastly, it's if it isn't that, it's parts. So you have simple parts, x sine x, and then you have a few that you've just got to know what to do, which is the integral of log x, and you know that that is 1 times log x, and so you set parts up where you integrate the 1 and you differentiate the log x. Same with arc sine x. And lastly is this very famous one, and right at the start you should say I equals it. Then you do integration by parts. then you do integration by parts again, and you'll end up with something that looks like this. Just made these numbers up, but it'll look very, very like this. And you think, oh my God, do I have to do yet another integration? No, you don't, because that's I. So you replace that with I. And then we can say, well, 1i take away 6i is negative 5i. And then I is equal to this times negative a fifth. Really nice. So that's basically all of integration.